Isn't our body amazing? This is red blood cells that carry oxygen throughout our entire body to all of our organs and our tissues. We have 35 trillion red blood cells in our body. We produce 2.4 million per second of red blood cells, and they only have a lifespan of 120 days. Let's look at cardiopulmonary blood flow. The areas that are blue is the deoxygenated blood, or hemoglobin, and the red areas are the oxygenated blood, or hemoglobin. So let's start in the right atrium, which is located here. The blood that's in the right atrium flows through this valve located here, which is called the tricuspid valve, and the blood flows into the right ventricle. Now, the muscle that surrounds the right ventricle is not as large as the left ventricle. And the reason that the right ventricle is not as large is because the right ventricle pumps against the pressures of the pulmonary system. And the pulmonary system's blood pressure is about 30/15. So it doesn't have to overcome as much pressure. So that is why the muscle is not as large. Once the blood leaves the right ventricle, it goes through the pulmonic valve here and into the pulmonary artery, which bifurcates into the left pulmonary artery and the right pulmonary artery. The left pulmonary artery and the right pulmonary artery dump blood into the capillary systems, which is this web-looking area that surrounds the alveoli. Your alveoli are the air sacs that are in your lungs where gas exchange occurs. So when it reaches this area, it will pick up oxygen and drop off CO2. And when we drop CO2 off, we will exhale it out. Once the hemoglobin picks up oxygen, it's going to flow from the pulmonary capillary system into the pulmonary veins. This one is the left, and this is the right pulmonary vein. And this dumps blood into the left atrium. Once the blood reaches the left atrium, it's going to flow through this valve, which is the mitral valve, also known as the bicuspid valve. And this will dump the blood into the left ventricle. Now, as I said before, the left ventricle has a larger muscle, and that's because the left ventricle, when it pumps blood out, it has to pump against the systemic blood pressure. And so that is the blood pressure of your body, which is roughly around 120/80. So it has to pump against a greater pressure. So the muscle needs to be larger. And then once the blood leaves the left ventricle, it goes through this last valve here, which is the aortic valve, and it goes into the ascending aorta, into the aortic arch, and then from the aortic arch, the blood will bifurcate off, and portions of it will go to the upper body to feed the head and the limbs, the upper portion of the body. It will feed the organs there, the oxygenated blood. And then the rest of it will go down into the descending aorta and feed the lower half of the body oxygen, as well as the abdominal organs. And so once the blood drops off oxygen, it's going to pick up carbon dioxide. And so at this point, after it drops the oxygen off, it now becomes deoxygenated blood again. And it will leave the upper portion of the body and go through the superior vena cava and drop blood back into the right atrium. And from the lower body, it will come back in through the inferior vena cava and drop blood into the right atrium. and then the process starts over again. If you were not already amazed, this is the rhythm that our heart makes every time the atria and the ventricles contract. This is called a normal sinus rhythm.